in behavior of rational functions. Like, what in the world is it talking about when it's talking about in behavior? So this particular one says, what does g of x approach x as x approaches positive infinity? So what is g of x? What is the y value approach as x approaches positive infinity? So what we're going to do is we're going to take this function, we're going to put it into Desmos, and we're going to kind of show you guys what it's talking about when it's talking about in behavior, okay? But there's stuff that you can also realize without having to type it in to Desmos where it would actually enter. So we have different options here, okay? We have different numbers. We have it's approaching positive infinity, negative infinity, 0 from below, 0 from above, 3/4, and 10/7. So what we're going to do is I want you guys to write down this function. All right, so I'm going to go ahead and write it down with you. We have g of x equals 3x squared minus 10x to the power of 4 over 4x squared minus 7 over x to the power of 4. So one of the things I need you guys to realize when you're dealing with a rational function, we're going to type in just the most basic of all rational functions. And I'm just going to put the parent function. It's going to be f of x equals 1 over x. So I want you guys to take a look at this real quick. All right, so what we're going to do, I'm going to type that in real quick. F of x equals 1 divided by x. So you can kind of take a look at this. So this function right here, you should have a graph of it in your journal. It has a vertical asymptote and it has a horizontal asymptote. All right, so the vertical asymptote is whatever makes the denominator equal to 0. So we have a vertical asymptote at x equals 0. That's what we have, okay? Now, you'll notice up here we have a 1, and here we have x to the power of 1. Technically, we could say we have x to the power of 0 times 1 over x to the power of 1. You'll notice that this degree is smaller than this degree. So there's a rule, okay? And the rule is, if you have an expression on top of another expression, so you have a of x. So right now we're just going to say, let's say a of x equals the number 1 and b of x equals the value of x. Well, technically this degree is smaller than this degree. All right? So if that happens, you have a horizontal asymptote at y equals 0. So we have a horizontal asymptote at y equals 0. So here's my horizontal asymptote right here at y equals 0. Then we have a vertical asymptote that runs vertically straight up and down at x equals 0. And those are the boundaries in the graph that have to be kept in our rational function. So if we take a look over here, we're going to talk about some rules. Okay, so here's some rules, some key concepts, and we're going to use this paper right here to kind of go over those rules. So make sure you have your journal. It says, when you have a function of a of x over b of x, and a of x and b of x are polynomial functions with no common factor, so nothing's been canceled out other than 1, and b of x cannot equal 0, all right? Basically, like it can't be the number 0. It says f of x has vertical asymptotes whenever the denominator of b of x is equal to 0. So on our particular problem, we had a vertical asymptote where x was equal to 0, because if you made x equal to 0, put a 0 in the denominator. All right, I'm going to go ahead and take a screenshot of this. Now, f of x has at most one horizontal asymptote. So each of these problems, that you'll have at most one horizontal asymptote. So I'm going to kind of write some stuff down real quick. I'm going to pause the video and then I'm going to type it in. So what we're going to do is we're going to go over each of these principles. Okay, so in blue, I'm just going to do, here's kind of rule number 1. It says, if the degree of a of x is greater than the degree of b of x, there is no horizontal asymptote. So here would be an example. I'm just going to do an example real quick. So if we had f of x equaled, let's say, x cubed plus 2x minus 1 all over x. All right, well, you can clearly see that this power right here is a 3, this power is a 1, and 3 is greater than 1. So if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. This rule would be there's no, I'm going to put HA, short for horizontal asymptote. Then let's take a look at the second rule. The second rule says if the degree of A of x is less than the degree of B of x, then the horizontal asymptote is y equals 0. So what I'm just going to do is I'm just going to reverse this. Here's scenario number 2. What if I said f of x was equal to, and I just reversed, I did the inverse, but like x over x cubed plus 2x minus 1. I'm just making these up here, okay? So you can clearly see now that the numerator, the degree of the numerator, is smaller than the degree of the denominator. So we are going to actually have a horizontal asymptote. I'll put H, A is at y equals 0. All right? So your horizontal asymptote will be at y equals 0. Whereas this one, there's going to be none. Okay? So over here, I'll just put none. So no horizontal asymptote. Now the last one is the one that's the most interesting, all right, is it says if the degree of A of x, which basically means whatever the function is, whatever the expression is in the numerator, is equal to the degree of B of x, then the horizontal asymptote is equal to the leading coefficient of A of x over the leading coefficient of B of x. Wonder what that looks like. So here we go. We're going to do f of x. And I'm just going to make something up here. I'm going to put 3x squared minus 4x over, let's put 4x squared plus 1. Now you'll notice right now that these degrees match. They're the highest degree and they match. So basically I have to take the leading coefficient over the leading coefficient. So this will have a horizontal asymptote. Put H, A, and it'll be at y equals 3 over 4. Now I'm going to go ahead and kind of prove this to you because we actually have that scenario on our particular problem. All right, we have the one that we're doing in the Khan Academy. We have scenario number 3 is what we have. You're like, what do you mean scenario number 3? Let's take a look at our problem here, okay? So you'll notice, what's the highest degree of 4? What's the highest degree of 4? And so our horizontal asymptote, all right, is going to end up being at negative 10 over negative 7, which actually becomes positive 10 over 7. But we're going to go ahead and type this in so you can see it. So right now, I'm going to go ahead and delete that and put a little fraction bar right here. We go. Let's go ahead and type this in. Let's take a look. We got 3x squared minus 10x to the power of 4. There we go. So 3x squared minus 10x to the power of 4 over 4x squared minus 7x to the power of 4. Here we go. 4x squared minus 7x to the power of 4. All right. Now I'm going to type in y equals 10 over 7. And I want you guys to see that this is right here. This is the horizontal asymptote that goes right through here. And you'll notice, basically, I'm going to go and draw on this graph so you guys can see. Oops, hold on. Now, in this graph right here, x is approaching negative infinity as it's going to the left. So as x is going to the left, it's approaching negative infinity. Well, what is f of x approaching? F of x is approaching this value known as 10 over 7. And over here, x, this is the arrow, is approaching positive infinity as it goes to the right. Well, what is f of x approaching? It's approaching 10 over 7. So you'll notice it's approaching the horizontal asymptote going to the right and going to the left. Just remember, that little arrow means approaches. Okay? Now, another way of saying approaches from the left into the right is a negative and a positive. We'll get to those examples in a little bit. Okay? So right now, what we're going to do is we are going to say, in this particular problem, all right, what's happening when g of x, this was g of x instead of f of x, sorry. As x approaches positive infinity, well, as it's approaching positive infinity, it's approaching 10 over 7. So I will go ahead and just type in 10 over 7. All right. Now that was just one problem, so I'm going to go ahead and go back and do it again. All right, in behavior right here. And we'll do a few more problems together until you guys get the hang of it. All right. Now this one says find the horizontal asymptote of p. So the first thing I'd like you to do is I'd like you to write this down, p of x. So you're going to write down p of x equals 13x plus 12 over 23x minus 12. Now, what we have to do is we need to go back and look at our scenarios, okay? So here we go. This is a scenario that, once again, the degree of the numerator, the degree of a of x, is the same as the degree of b of x. And I know this because I can clearly see that this is x to the power of 1 and this is x to the power of 1. And when that's the case, your horizontal asymptote, I'm going to put HA, short for horizontal asymptote, will be at y equals 13 over 23 because these degrees are the same. So I'm going to choose answer choice B as my answer. It was very similar to our last problem that we just did. All right, next one. It says find the horizontal asymptote of P. Now this one, if you look at it, this is a great example for you to write down. P of x equals 3x cubed minus 9 all over 2x squared plus 7. Now this scenario, actually look at this degree. That's a 3. That's a 2. All right, so I'm going to go back to our quick little reference guide right here. And it says, if a of x, which is the numerator, is greater than the degree of b of x, then there is no horizontal asymptote. Well, look, that's a 3. That's a 2. Therefore, we're going to say this graph does not have a horizontal asymptote. In fact, this actually follows the rule for what's called a slant or oblique asymptote. All right? So it actually is going to have a slant or oblique asymptote. I'm going to show you how to find that. Okay? It doesn't ask you to find this on this particular problem. Our answer is going to be answer choice E, but I do want to show you how to find a slant or an oblique asymptote. So there's kind of a cool rule. Check this out. All right, so I'm going to go, let's see here, next page real quick. So here's our rule for oblique asymptote. Here's what a slant asymptote looks like, okay? If a of x over b of x, if it's simply 1 degree higher, see that's a 4 and that's a 3, then if you actually divide them, then you'll be able to find the equation for the slant asymptote. And that's what we're going to do right now. We're going to go ahead and show you guys how to do that. All right, so what we're going to do is we're going to do some long division here. We're going to take 3x cubed minus 9, and we're going to divide into that 2x squared plus 7. I'm going to show you guys how to find the slant asymptote. So you're like, well, how in the world do I do this? Well, what number would you have to put right here to get this to become 3x cubed? Well, that number has to be 3 over 2. 3 over 2 times x. Because 2x squared times 3 over 2x becomes, these 2's will cancel out, that becomes 3x cubed. And then when you multiply 3 over 2x times 7, that becomes 21 over 2x. And what we have to do is we have to subtract these. And this zeroes out. This becomes a negative 21 over 2x. I'm going to go ahead and bring down this minus 9. Just bringing down the minus 9. And this one's a little bit trickier. It's like, well, how in the world does 2x squared go into negative 21 over 2x? It does not. So basically, this is our slant asymptote. Since this does not go into this, our slant asymptote would be y equals 3 over 2x. x, because this does not go into this. And so this is what's known as our remainder. That's what our remainder is. So hold on, I'm going to go ahead and type it in to Desmos, and we'll be able to see it. So to save some time here, I typed in our original equation and our slant asymptote, and you can see as I zoom out that graph, they just get really close to each other. And so this right here, that crosses over, but then it continues. If we were to zoom in, you would see that it just keeps getting closer and closer and closer to that 3/2. And that's what asymptotes do. They provide boundaries for those rational functions. Over here, you'll see over time, it just keeps getting closer and closer and closer. All right, so this one, in review, this one did not have a horizontal asymptote, but it did have a slant asymptote. And once again, how do you find your slant asymptote? Here's a picture of how to find it. Basically, you just divide the equations, and when you don't worry about the remainder, you go and do it, and however many times it goes into it, that's your answer. You don't worry about the remainder. All right, so here we go. I say this does not have a horizontal asymptote. Let's move on to our next question. Now, in this particular question, all right, you will notice that we have an x squared up in the numerator and we have an x cubed down in the denominator. All right, so if you look at that, if you look at 14x squared minus 9 over 35x minus x cubed, the only thing I'm worried about is this power and this power. And whenever this number is less than this number, I know my horizontal asymptote is going to be y equals 0. So when it says find the horizontal asymptote of p, I know it's going to be at y equals 0 because of our original, go back here, when we have a of x is less than the degree of b of x, then the horizontal asymptote is y equals 0. And so those are the rules you're going to want to write down when you're doing these problems. This is going to be answer choice A, because 2 is less than 3. So once you write down the rules, you'll be fine. Now this one's not talking about the horizontal asymptote necessarily. What we have to do is we need to write this down. It says, what does g of x approaches negative infinity? So we're going to go ahead and write this down, and we're going to take a look at it. It says g of x equals 2x to the power of 8 plus 3x cubed plus 5 all over x cubed minus x to the power of 8. Now you're going to notice right here that we have this power and we have this power. All right? And so one thing you need to understand is these are the same power. So that's going to go into our third scenario. So we are going to have a horizontal asymptote at the coefficient in front of this divided by the coefficient in front of this. So basically, we are going to have a horizontal asymptote at y equals 2 divided by -1, or y equals -2. So it says, what does g of x approach as x approaches negative infinity? We're going to type this in, so we're going to take a look at it. Okay. So let's go ahead, and I will go ahead and pause the video and go ahead and type it in. All right. So here's our graph. I've typed it in. I've typed in our horizontal asymptote at y equals -2. You can kind of, I'll go ahead and take that out real quick so you can see. All right, so basically we have an 8, power of 8, power of 8, 2 divided by -1 is -2, so we have a horizontal asymptote right here. But our question asks us, it says, what does g of x approaches negative infinity? So let's go over here. So x is approaching negative infinity over here. So as x is going to the left, all right, so as x approaches negative infinity, what is g of x approaching? Well, it looks like it's approaching -2. It's like it's just getting closer and closer and closer to -2. And if that question asked us, if x was approaching positive infinity, all right, what is g of x approaching? G of x is approaching -2 as well. Okay. Now let me kind of talk to you guys about this right here. See, we have 0, we have 1 right here, all right, and then this right here is 2. So let's say we had a point right here, and I said, hey, as x is approaching, let's say that was a 1.5. Like as x is approaching 1.5, what is g of x approaching? Well, from the right side, it looks like it's approaching a -3. And from the left side, it looks like it's also approaching a -3. So that's kind of a way of, it's just an example of how to interpret it from the left. So if we said, as x approaches 1.5 from the left, it's approaching -3. And if we wanted to say from the right, we'd say a plus from the right side. So this is approaching it from the right side. This is approaching it from the left side. So if it's from the right, sometimes they put approaches with a positive, and from the left, they will change that little positive to a negative like that. Okay, and we'll probably see some of those as we go along. But for this one, it looks like it's going to be approaching -2. Let's choose one answer. All right, and so it says see step-by-step solution. You can take a look at that. There's our graph right there. It says g of x approaches -2 as x approaches -infinity. So from going just like our graph that we had. Okay. So hopefully that was helpful in helping you guys understand end behavior. End behavior is as it's approaching to the left, going to the right forever. Just remember, as it's going to the right, that's known as x is approaching positive infinity, and as x is approaching negative infinity, it's going to the left.